In this video, we're going to see actually two different formulas. We'll start with everybody's favorite, the quadratic formula, ooh, and then we're going to do the distance formula. And again, what we're practicing is how to do math in Java. So let's open up the quadratic formula program. And in here, unsurprisingly, we're going to write a little program that does the quadratic formula. Now, what is the quadratic formula? Well, hopefully you were taught what it is. I learned it through a little song, which it kind of goes to the tune of Pop Goes the Weasel, which is x is equal to negative v plus or minus a square root v squared minus 4ac all over 2a. And that's what we're going to code here, basically, is that. So what values do I need to actually do the quadratic formula? Don't I need an a, b, and a c? So let's do this. Let's say double a equals. We learned that there was a method called readInt that we can use in console programs. Well, unsurprisingly, there's a method called readDouble. And I'm going to just do a equals, and same thing, double b equals readDouble b equals, and double c equals readDouble c equals. Now that we have a, b, and c, I need to do the quadratic formula. Now we know that there's a little plus or minus in the quadratic formula, and there's actually no way to do plus or minus in Java as kind of one thing. So we're going to need to make two different variables for kind of two solutions. So let's do this. Double x1, and I'm using x1 and x2 because that's how it's commonly done in your math class. If we were doing this in CS, and we made the quadratic formula, maybe we use x0, x1. Let's do that. Let's do x0 equals negative b plus. We just learned how to do square root. It's math.squirt. And then b squared. I could just type b times b here, but just to practice, let's do math.pow b2 minus, I do have to write 4 times a times c. Otherwise, Java won't know to multiply those. It'll try to think it's a variable, over 2 times a. Now, I've forgotten some really vital things in here. Remember from the last video that Java will actually always obey order of operations, which means that my parentheses that I put in these mathematical expressions are actually really important. The same way that when you do it on your TI-84 graphing calculator, the parentheses are super important. So I do actually need parentheses around the bottom here and parentheses around the entire numerator here. So from here all the way to the minus b at the front. And then everyone's favorite thing, let's copy this. Let's paste it down below. And the only two things that have to change are x0 has to become x1, and this plus here needs to become a minus. And then let's just do a print line to print them out. So I'm going to do print line solutions x0 and a space between them x1. And let's actually see what this looks like. So I'm going to compile this. Let's put it over here. And let's go ahead and run it. Let me make this window a little bit smaller. Maybe. Maybe not. Okay, let's do 1, 2, and negative 15, which does kind of factor evenly. And there we go, we get 3 and negative 5. You might notice, though, that depending on how you run this, it might give you a slightly weird output. So let me go ahead and run it again with some different numbers. Here I'm going to run it. Let's do 1, 2, and 3. And weirdly, I get nan, or non. This actually stands for not a number. And I want us to think about what's actually happening here, right? I'm just using this as notes. This isn't kind of code I'm going to type. What is 1, 2, and 3? Well, that's x squared plus 2x plus 3. And if I actually plug this into the quadratic formula, what do I get? Well, negative 2 plus, I'll just do square root like this, of 2 squared, which is 4, minus 4 times 3 times 1, actually all over 1. And I'm kind of, again, missing some parentheses here. Oh, we'll make this. Isn't this going to be an issue? What am I doing here is I'm going to be square rooting a negative number, which we know in math we're actually not allowed to do. So when I get this not a number, what's actually happening is that this is an imaginary root. And Java actually doesn't know how to handle imaginary numbers, so it actually just gives you this. There's another thing that might happen if you do something like this. Let's try to run this with 0, 2, and 6. And you get this weird kind of negative infinity. What's happening if I make a 0? Aren't I actually dividing by 0 over here, which we also know in math is not something I'm allowed to do. So it actually just gives me this kind of crazy answer. There are certain versions of Java that will actually give you an error for trying to divide by 0 in certain cases. So in this case it didn't, but we did get kind of this weird sort of answer. So there's the quadratic formula again, everyone's favorite. Let's close out of this. And let's do the other formula, which is the distance formula. When I say distance formula, what I really mean is, let's say I have 2 coordinate points, so like an x0, x1, or sorry, x0, y0, and an x1, y1. Can you find the distance between those 2 points? So let's do this. We're going to do a bunch of read doubles. So I'm going to do double x0 equals read double x0 equals, and we'll just take this. We're going to have get 4 numbers. Let's do x0. Let's do then y0 for the next one. Let's do x1 and y1. And make sure you change them in here. This is y0, this is x1, and this is y1. So we're bringing in 4 numbers. Those represent our 2 xy coordinate points. Then let's do this. Print line, distance, and I'm just going to pass all these in. x0, y0, x1, y1. You might be wondering, is distance a method that's built into Java? If I click off of it, you'll see kind of right off the bat, no, it's not. We will actually have to write the distance method. So let's go down here and let's do public. What type does this method probably return? Well, I kind of get to choose because I'm writing the method, but what type should really distance be is probably a double. We know it's called distance. How many parameters will this method take? Actually, we'll take 4 parameters, right? And all of them are doubles. So I'm going to do double x0, double y0, double x1, oh gosh, and double y1. Now, you might be wondering, how can you have the same names for variables up here and for these parameters? But I'll have you remember that variables exist within the curly braces where they're defined. That actually is true for parameters as well. So these parameters actually only exist inside the distance method. So kind of these x0, y0, x1, y1 are different than these ones, even though they're going to end up being the same numbers. So what's the distance formula? It's actually square root of x1 minus x0 squared plus y1 minus y0 squared. I think we can actually do this in one line. Since the word here is not void, that means I need that special word return. And again, we're practicing our math skills. So let's do math.squirt, math.pow, x1 minus minus x0, that's taken to the second power, plus math.pow, y1 minus y0, taken to the second power. Now, before we run this and just make sure it works, I do want to bring up one thing. Remember all the way back to the days of Carol, how long did we say a method should be? What was that guideline? Didn't we actually say it should be 2 to 8 lines? And we did just write a method here that's only 1 line of code. Well, one of the exceptions to that 2 to 8 lines is actually the idea of I'm making a method that does some formula. So in this case, I kind of have this gross mathematical formula that I've coded into this method. And it's actually not a crazy idea to think that if I have this formula, I might want to use it multiple times in whatever program I made it in. So in that case, it's actually really nice to have this as a method. I also think that even though this is only one line of code, if you're typing this all over a program where you're using it, it's kind of gross to look at. So it's a little bit nice just to say, hey, I'm getting the distance between these things. Let's just make sure this works. So let's compile and let's run my distance formula. And let's do 0, 0, 0, 4, just so it's easy. I should get 4 for this, and looks like I do. So again, we're just in the camp of practicing how to do math in Java. Let's look at one more program in this, and this is going to talk a little bit more about doubles. In the last video, we heard that oftentimes we will want to use an int if an int makes sense to use. And the justification I used then was this idea of kind of what's the next number. The number after 9 is 10, but what's the number after 9.3? We don't really know how to answer that question. Well, there's one other justification for why you might want to use an int instead of a double in some scenarios. So I'm going to close out of this. Don't run this program, but let's open up the program BeCarefulWithDoubles, and let's think about what's happening here. Look, here, what am I doing? I'm taking the square root of 5 and then taking the result of that and squaring it. So what would I expect to get back from this is probably the number 5, right? If I take a square root and then square it, I should get the same number back. Let's go ahead and run this and let's see what's actually happening. Oh, funky, right? It's weirdly a little bit off. So I have to teach you a new thing about doubles, which is that doubles are actually inexact. You can see here that a double actually stores a certain number of decimal points, and that's part of how doubles work in Java, is that they're able to store kind of up to a certain decimal point, which means somewhere at the end of that decimal point, there's got to be some sort of rounding or kind of cutting off the decimal going on. I'm losing information in a double. It can't actually store everything. Think about a number like pi. Pi has infinite digits, but a double would actually stop it at like 12 digits. So you can see that a double is inexact, which means that sometimes when I do mathematical operations like this, I'm actually going to be off by just a little bit. So what is one other reason or justification for using ints versus doubles is ints will always be exactly the number you say. An int is a whole number. And again, like I said, there's no inexactness about that. If I say int x equals 47 and then do some math with it, I'm not going to be losing any information from that. But if I make that a double, there's a chance that because of some rounding or something else that's going on, I could actually lose some information down to like the 12th decimal point. You're not always going to care all that much about that 12th decimal point, but every now and then this will come up, and we'll see it come up once or twice in more examples in this unit. So these have been 3 examples where we've been kind of looking at some of these principles of math in Java that we've been talking about for kind of the last few videos.